Everyone's piling into Nvidia, Palantir, and Meta, but the real AI money isn't only in the models. It's deeply embedded in the foundational infrastructure, the very plumbing that makes AI possible. If I had to start from zero today, I'd follow three invisible toll booths every GPU rack pays: kilowatts, coolant, and cables. These are the essential, often overlooked, components driving the AI revolution. In just 5 minutes, I'll show you how to gain significant AI exposure without chasing the same three widely discussed tickers, focusing instead on the critical underlying technologies. AI clusters are exploding in size and complexity, demanding unprecedented levels of resources. More clusters mean a dramatic increase in electricity consumption, significantly more heat generation, and an exponential surge in network traffic. While the chips themselves grab all the headlines, these three fundamental bottlenecks collect tolls on every single expansion, regardless of which company ultimately wins the model war. First, let's talk about power. Before a single AI model can even begin to run, operators require robust electrical infrastructure, including massive transformers, sophisticated switchgear, and uninterruptible power supply systems. They also need clean, reliable power paths extending directly from the grid to each individual server rack. This isn't just hype, it's fundamental physics that cannot be circumvented. Companies specializing in electrical infrastructure and power provision inherently scale with every new data center build and every significant upgrade. Their growth is directly tied to the expansion of AI. What to watch for in this sector are growing backlogs, indicating high demand, longer lead times for equipment, and customers publicly announcing new megawatts coming online, signaling significant capacity expansion. Risks include project timing delays, complex permitting processes, and utility regulation changes. While steadier than volatile chip markets, project dates can slip, so it's wise to add during boring weeks, not viral ones. Second, let's consider cooling. High-power AI chips generate an immense amount of heat, and traditional air cooling alone is rapidly hitting its limits in today's incredibly dense server racks. Consequently, liquid cooling solutions, such as cold plates, intricate manifolds, and rear-door heat exchangers, are increasingly appearing in new data center rollouts and upgrades. As power density continues to climb, thermal management vendors sell more specialized gear and provide essential services. This creates a recurring revenue stream, moving beyond one-off sales. Retrofits of existing data centers into multi-year revenue streams, rather than just single project wins, further solidify the financial outlook for these specialized cooling providers. Risks include the adoption of industry standards, site-specific constraints that complicate installation, and a vendor's proven ability to deliver solutions at hyperscale, which is crucial for large AI deployments. Think of a GPU cluster like a high-performance pizza oven. Just as better ventilation allows for more pizzas per hour, superior cooling directly translates to more computational output. Conversely, poor cooling throttles performance, severely limiting the number of calculations a cluster can perform, which directly impacts revenue. This is why operators gladly pay the cooling bill. Third, let's delve into networking. Training advanced AI models isn't about one incredibly fast chip. It's about vast teams of chips communicating with each other at insane, ultra-low latency speeds. This demanding environment requires high-bandwidth switches, advanced optical transceivers, and smarter, more efficient network fabrics to handle the immense data flow. As AI clusters continue to grow, the need for more switches and progressively faster links intensifies, driving upgrades from 100 gigabit Ethernet to 400G, and now rapidly towards 800G. Networking vendors win on both the sheer unit count of devices sold and the speed mix as customers continuously upgrade their infrastructure to meet escalating AI demands. Risks include customer concentration, where a few large clients dominate sales, and potential capital expenditure pauses. However, when spending resumes, widening network lanes is often the first priority. Now for a bonus toll booth, the landlord, specifically data center REITs. These companies rent out powered shells and critical interconnection hubs, with their value measured in megawatts, not traditional square feet. When evaluating these REITs, watch their balance sheets, pre-leasing activity, access to reliable power sources, and the crucial time-to-power metric, which indicates how quickly new capacity can come online. Risks for data center REITs include fluctuating interest rates, which impact financing costs, and intense competition for prime grid connections, a finite and increasingly valuable resource. To turn this information into actionable investment strategies, consider building a basket with two distinct buckets. Bucket A focuses on the core plumbing of AI infrastructure. This includes selecting one strong name in power infrastructure, one in advanced cooling solutions, and one in high-bandwidth networking. These are the foundational elements. Bucket B, optionally, includes a data center REIT to gain exposure to the underlying capacity growth. This provides a different angle on the AI infrastructure play. Remember to add positions slowly during quiet weeks, avoiding the frenzy of viral news cycles. Patience is key in building a resilient portfolio in this space. My favorite cross-check for these investments involves capacity signals. For power and cooling, track new megawatts coming online and lead times for equipment, as these indicate real demand. For networking, monitor the share of 400G and 800G deployments and the software attach rate, which signifies deeper integration and value-add services. When these capacity signals trend up together, it's a strong indication that demand is genuinely robust and not merely driven by fleeting headlines or speculative hype. What can potentially go wrong? Budget pauses from large customers, project delays in construction, power constraints limiting expansion, and valuations sprinting ahead of underlying reality. That's investing, of course, but the key is understanding the risk shape. Chip investments often swing wildly with hype cycles, whereas the plumbing compounds steadily with actual deployments. To recap, we've explored 3 smart ways to invest in AI beyond the usual suspects like Nvidia, Palantir, and Meta, focusing on power, cooling, and networking, plus the crucial role of the data center landlord. If you're interested in a Part 2 deep dive where I rate one specific company in each of these buckets using the capacity signals we discussed, please comment plumbing below. Before you subscribe, I encourage you to watch one more video from this channel. Let me earn that click by consistently providing valuable insights.